Today what we're going to be discussing is the processing of oil and natural gas. So basically once we find oil, how do we get it out of the ground and what is the process to go from getting it out of the ground to actually using it within your home or your life? So there is a general process. The first one is the exploration. So what is exploration? Exploration is where you're exploring to figure out where the oil is. Production is when you're trying to bring out the oil from the ground. Bring out oil or gas from ground. Transportation is going from dig site, to the refinery. So how do we get it from where we dug to refining it into something that we could actually use? To the refinery. Okay, then we are going to refine it, which means we are going to separate it based on uses. And then you are going to manufacture it possibly into a direct use, and then you are going to use it itself. So how do we do this first part of digging or drilling? Okay, so typically in the past, what we would do is we just do a vertical drill, which is that guy. So you just dig down and you'd hope that there's a big pocket of oil and it would just, based off of pressure, shoot up. Okay, so that's when you see those rockets basically of oil just squirting out of the drills. That's what that would be. Okay, but what's happening now is we're using so much of it and it's very expensive to start this, like the drilling pad and things like that. And once you find a good bed where oil is probable, meaning that it is porous and probably permeable, hopefully. Okay. What you'll want to do is you'll want to take that whole bed of it, right? But that would mean originally, if you were trying to just do vertical ones, you dig here, you keep digging here, you keep digging here. That's very, very expensive. So what they've done is they've actually learned how to horizontal drill. And what that means is that you drill horizontally. So you form basically a 90-degree angle in it, right? So what is the process? And how do we do it? So first we drill down vertically. And then what we do is once we find the bed of rock that we actually want to focus on where the oil would be found, we then do a 90-degree turn. Okay, so now this whole pipe is within the bed that we want it in. Okay, so then what you can do is if it is permeable rock, then what you're doing is with this piping, you're going to do a perforation. What a perforation does is basically it causes holes right here in the pipe, and then it also causes a little bit of holes up here. So what that does is it allows any oil that's in here directly, it can go whoop right into that little pipe. Okay, but that's only if it's actually permeable. And remember what permeable means is if you have these like rocks, the oil can flow easily from one point to the other. But that's not how all of this is, right? So what they end up doing is they do fracking or fracturing the stuff. And what you do for fracking or fracturing is after your perforation, so you've created holes in your pipe, what you do is you shoot out basically water and some fluid and sand. And what it does is you kind of cause this explosion to cause these little fractures, little I guess, paths in the bedrock. And what that does is it gets all of these little pockets that didn't have any path. So right here we have a pore, right? What it does is it opens up that pore. So if you shoot some water and sand through it, this now becomes an open path to where the oil can go into the pipe. Okay, and that's fracking or fracturing. So let's try to explain once again what is happening during fracking. Okay, so this is a fracking one. What you're going to do is you're going to drill down. Then you are going to put your pipe, once you find the nice layer of bedrock, you are going to go and do a 90-degree horizontal pipe. Then you are going to do your perforations, which is basically holes in your pipe. Now, if you have really like a solid amount of oil there, the oil will automatically go into the pipe and you'll be done, because due to pressure, it will go up to the top, it will surface. But that's not always the case. In fact, we've used so much, what they want to do is that they want to get as much out of these little areas as possible and get where it's not permeable. So what they do is they insert the liquid of combination of water and sand and some other chemicals, and they cause these other little fractures. And now notice, look at how many little paths they had. Whereas before, if you just had the perforations right here and here, these paths, these little guys, would not be able to get the oil into there, into the pipe. So by fracking, you can actually do this. Now, if you wanna like look at the problems with it, if you frack too much, like it goes a little bit too high, what do you notice up here? Uh-oh, these bad chemicals are now in your water source. Okay, so they have to be very, very careful, and that's one big problem with fracking that they found, is that it actually can contaminate your water. Okay, so once again, what is the purpose of fracking? The purpose of fracking is that it allows you to get natural gas and oil in pockets that are porous, really, but they're not very permeable. So the path of the oil cannot get into your pipe. Okay, and so you allow these fractures to create paths. That's the whole purpose of fracking, is to create paths for the oil to go from their little pore into your pipe. So what are some problems? As we've noticed, as I've talked about before, if you frack too high or you make a mistake, you can get these chemicals, which are very toxic, can get into the water source. So where does this water source go? It goes into your house. And what actually is going into your house, you could also get some oil, you could get some natural gas. What they've done is they've noticed that in places that frack a lot, you can sometimes, because they've exposed their water source to the natural gas and stuff, you can actually light your water on fire, which is absolutely disturbing if that's what you're drinking. It's flammable materials. It also can cause unstable bedrock, which leads to a lot of earthquakes. In fact, in Oklahoma, they used to not have very many earthquakes, and now there are over like 1,000. Now, those are small ones a year. So it definitely exasperates the system. And why? Because look at what you're doing. You're causing cracks in your bedrock. That makes sense that you would have earthquakes. All right, so let's look at this map. The brown areas are where fracking is. So circle your state. Where and does it have fracking? So I hope by now at this age you know that you live in Illinois, which is right here. So look, do we have brown in that state? Yes, we do. So yes, we do have fracking in Illinois. Okay, so now we've explored it. We now are ready to produce it. Okay, so production means is where you're actually taking the oil and the natural gas out of the ground. And so what you're going to do, it's not very complex. That's why that whole drilling thing and the fracking, that's why you want to invest your money there, because that equipment and that process is extremely expensive. But the actual process of bringing the oil out of the ground is not very difficult. And the reason why is because they base it off of basically pressure differences. There are two types of pumps that we used in order to do this production, and one is the Christmas tree. I personally have never seen this Christmas tree. First off, it doesn't even really look like a Christmas tree to me. It just is a lot of valves and gauges, as they say. And then the other one is a horse head pump. Now, if you've ever been down to central Illinois, I've seen these a lot in the fields. I go all the time to Shelbyville, Illinois, which is very much in central Illinois, and I'll see these horsehead oil pumps going all the time on these farmers' lands. And so what that means is that the farmer either gave the rights to the oil companies to dig these rigs and put the horsehead pump in it, and then they either get some of the proceeds, or they just automatically get a lump sum in the beginning to have it. You get $10,000 a year, let's say, to have this horsehead pump on your land. And the farmer says, sounds great, you can do it. All right, so next thing is that sometimes the oil is too heavy. So what they'll do is so the pressure doesn't work right. So what they'll do is they'll do an injection well. They'll add a second well. And what they'll do with that second well is they'll inject steam or some sort of gas. And what that does is it changes the pressure in the bedrock in the oil. And when it does that, it will allow and force the oil out naturally. Okay, so if this oil kind of becomes stagnant, but you know it's there, that might be because the oil is too heavy. So what they'll do is, once again, they will add a second well, which will then allow this well, they'll shoot some gas in it. This is not an oil well. You won't be getting oil from it. They'll shoot some gas or some steam through it, which causes a pressure difference, which will then force the oil out of the production well. So now that we've produced it, now we need to transport it. So how do you transport oil? Because you'll transport oil separately from how you'll transport natural gas, okay? Because one is a gas, one is a liquid, obviously. So how do we transport oil? There are 3 ways that we do it because we need to transport it from where we produced it to now where we are going to refine it. How do we do it? We do it through pipelines. This is an example of a pipeline. We use oil tankers, which is like a ship, and then you also can see some tanker trucks, which are trucks that have the oil in it. So you'll take, I-80, right, to get it to the refinery. So natural gas, how natural gas is transported is always done in underground pipes. So here is your transportation. If you look at this map, where are most natural gas taken? This area, right? There's a lot over here. Okay, so that's where natural gas is explored and taken out and produced, and then they will transfer it to all the areas to where they need to refine it. So now we're ready to refine it. The problem actually, and historically, if you think about oil, farmers used to have oil actually just sitting on their fields originally, a long, long time ago, right? And the farmers were actually angry about that because they had no use of this oil. They wanted to dig and find water wells, not oil wells. And the problem was is they didn't know what to do with it because petroleum has no real sources of use just naturally. What you have to do is you have to refine it and change it and separate it into their individual components, and then those can be used for their specific needs. So what you do is you actually do a fractioning tower, okay? And this is the process of where it's called a distillation it's the distillation process. And what you do is you put basically your crude oil. So crude oil is the oil that you get from the ground, and you insert it into this huge tower. And what this tower is it's called gradient by temperature. And so if you notice and you look at down here on the bottom, this is a lot hotter than up here, okay? So it's a lot hotter, if you look at it, it's 350 degrees Celsius, and then it gets up to 25 degrees Celsius, which is room temperature. But it's very, very hot on the bottom, and then it slowly gets cooler as you go up. But what you notice is that you're trying to separate these things based off of their boiling points. Okay, and what you're trying to do is you're separating these hydrocarbons based off of their boiling points. If you remember back to our hydrocarbon PowerPoint, what you should remember is that things with carbons 1 through 5 will be naturally a gas, and then things that are 6 through 18 are going to be liquid, and then things that are 18 plus are going to be solids. So we're really focused on these guys, the 6 through 18, because it's going to be crude oil, which is going to be your liquid. So you're going to put it in and you're going to heat it up. Now, because everything is based off of boiling points, if you start getting it cooler, these guys like diesel oil will start cooling down. First, it'll become a gas, okay, because it becomes a gas at 350 degrees. I'm going to erase this. So let's say we're going to talk about kerosene. So kerosene becomes a gas at 350 degrees. You have these little gas particles. They're going to go up. And then at this temperature, I'm totally making up this temperature. Let's say it is 150 degrees Celsius. At 150 degrees Celsius, kerosene will then go back into the liquid state. So what happens is it will not continue to float up the tube because it's not a gas. It will condense and be able to be taken out at this 150 degrees. I personally would watch the videos that we've also attached about distillation. They do, or fractional distillation is really what it's called. They do a really, really good job with visually about what's happening with these little particles, okay? But basically what you're doing is you're separating based off a boiling point. All right, so label the areas in the tower with the high and the low boiling points. So gases should have very, let's see, low boiling points. And the reason why it's a low boiling point is if it's at room temperature, it's already boiled if it's a gas, right? It's already gone from a liquid to a gas at room temperature, so it's obviously very low. Whereas the high boiling points will be more at your bottom, okay? All right, so once we look at, let's now focus on we have this crude oil, we can separate it due to fractional distillation. What actually, if I had a barrel of oil, what could it percentage-wise it be turned into? And if you look at it, 43% of it goes into gasoline, 25% goes into diesel, jet fuel, other products, petroleum, heavy fuel oil, heating oil is only 2.27%. So if you look at it, you've got gasoline, diesel, jet fuel. What is primarily oil turned into? Transportation. That's right. And so if we look at some products that we've got gasoline. This is the thing that I kind of looked at on the previous page. But if you look at it, most of these guys, what are they used for? They are used for transportation. So most oil is actually used to move from point A to point B. Okay, but oil is also used in a lot of other things. What is the primary one that we use it in? Plastics. So your toothbrush, your toothpaste, your shampoo, your contact lenses, carpeting, CDs, ink. You guys don't even use CDs anymore. Anything that is plastic has originated from oil. Okay, so not only do we use most of it towards transportation, but we also use it in our everyday lives and for goods and household items. So that was oil, which is different from, or petroleum, and this is different from natural gas, okay? Natural gas is obviously gas. It has a small number of carbons in a hydrocarbon. Remember, you're talking because it's a natural gas, it's going to be 1 through 5. It's going to have like either C1, H something to C5, H something. Okay, and the processing is actually a little bit simpler because you're only dealing with these 5 guys and it's a gas already. So what they're going to try to do is they're going to remove any extra water that's a vapor in it, and they're going to remove any hydrocarbons that are liquids because that would not be C1 through C5. And then what they're going to do is, so now you're dealing with pure gases at this point, right? And you're going to compress it using pressure. And when you pressurize a gas, what happens? It will go into a liquid. Okay, and this liquid is then transported to the pipes that are underground. Okay, it's a lot easier to transport the liquid than a gas. It takes up a lot less space. It's a lot more dense, so it's a lot easier. All right, so let's look at the uses for petroleum versus natural gas. Remember, petroleum we think of as oil, that crude oil. So where do we notice for petroleum? Vast majority is through transportation. When you look at natural gas, we've got power, we've got residential, we have very little transportation, industrial use. So this is mostly natural gas is used in your house to heat it up, to turn on your lights. Okay, a lot of our plants are natural gas plants nowadays. You never hear of an oil plant, okay, for like an energy source for electricity. You won't have an oil plant. What is the oil used? Once again, it's used for transportation, but you will have a natural gas power plant because we use natural gas a lot on stoves, but also for our electricity use. All right, so summary of oil and natural gas. So there are positives, but there are also extremely a lot of negatives, right? So first off, what is an advantage of oil and natural gas? It is widely available. That means we can find it throughout the United States. It's not in a very, very small part of the world. It's seen throughout the entire world. It's a very simple combustion process, meaning you're not dealing with nuclear reactions. It's extremely easy, right? And you can use that energy directly into heat and other electricity. Okay, it's also relatively inexpensive. It's easily distributed. We already have a good infrastructure in place, meaning we can get from where we dug to where we need the source easily. We use the boats or we use the pipelines, things like that. And per small amount of space, it actually has a very high energy content. Okay, it's not like burning wood. It's got more than that energy. So it's pretty productive in that sense. The problems with it is that it's non-renewable. So once we're out, we are done. So if we want plastic, we better stop using oil as much as we use for transportation, right? Okay, we've got, it produces, because of the combustion reaction, it produces our main source of carbon dioxide or greenhouse gases. As we've talked about, when you're traveling, right, you're producing a lot of these greenhouse gases. Why? Because you're burning it through this combustion reaction of the oil, the gasoline, and producing these CO2 products. It also makes air pollution. I'm not talking about the greenhouse gases. I'm talking about, like, it creates the soot and all this other stuff. It's the byproducts that occur during this combustion reaction of basically lighting this stuff on fire. Price instability and cost rising. So gasoline is very expensive, depending on just the world, right? And the world economics. Do we have good relations with the people who are digging out the oil, who have a good source? If yes, then our oil prices might be down. If no, then it's going to be skyrocketing, right? We also rely on imports, meaning we don't have the best source of oil in the United States, so we have to resource out to go look at other countries. And there are a lot of environmental impacts. Why? Because we're digging, we're drilling, we're causing fracking, we're causing these earthquakes, we're um, ruining our water sources possibly. And then we're also, I mean, we're doing a lot of processing and things like that with it, which also takes in energy or uses up energy. So it's a little bit more complicated, right, than just, oh, this is good, this is bad. There's positives and there's also negatives. All right, hopefully you have a solid understanding of this process of digging out oil and then using it for something good.